Okay, cool. So I'll start, and what I'll say is, let's talk about Omnia. And this is a dev call. I'm a little bit upset. I mean, there's more people here, so that's fine. And we couldn't fit all of you into the dev chat, but it's harder for you to now start saying something. Whereas before, you're sort of available to chat. Do stick your hand up if you want to say stuff or whatever. And I think Neo will sort that out, and then he can pop you up on stage. I wish it was that we could all just be in a room and people would just speak when they wanted to, but that wasn't possible. There's a limit. So we're doing it on this big stage. Blah, blah, blah. Okay, no props. But stick your hand up if you want to say anything. So let's talk about Omnia. And this is going to be, I want this to be quite techie. Yeah, so I will try to explain it in layman's terms, but this is meant to be a dev call. And I want some devs to understand this stuff because, as always, the more people that understand something, the better. So, but I am trying to make this as baseline as possible so that as many of you can understand what I'm talking about as possible. So what is Omnia? Omnia is our scaling solution. Omnia is what we at Minima are going to use to allow us to have massive transaction throughput. Use, because a lot of people have been asking me, have you done a test to see how fast, like what can you do? And, what's the throughput and everything? And I think there's a misunderstanding here because it's not magic. Yeah, this isn't voodoo. And it's actually very easy to explain what we're talking about here when we're talking about Omnia. So imagine the whole world, every single person, 8 billion people on the planet. And somehow we're going to coordinate and we're going to say tomorrow at 12 o'clock GMT, I want you to be standing next to someone. Okay, tomorrow at 12 o'clock GMT. So the whole planet, for some reason, they agree to this. And I say, I want you to have a pound coin on you or a dollar bill. Yeah, I want you to have a dollar bill. How to sort that out is another issue. But let's just say tomorrow at 12 o'clock GMT, I want everyone on the planet, 8 billion people, to stand next to someone. All right, you're standing next to someone. And then at 12:01 exactly, I want you to give your dollar bill to the person standing next to you. Two of you. I mean, if there's three, that might be like that. But if there's two of you, you're going to just do that. You're just going to give them that. Yeah. And in fact, I'm going to say it can be a random number from $1 to $10. I don't care. But I want you to give that to the person next to you. What's just happened? What's just happened is that we've just done 8 billion transactions in 1 second. Yeah. I'm not being funny about this. It's like you've just done 8 billion transactions. 8 billion transactions just took on at 12:01 tomorrow GMT. 8 billion of you are standing together. You gave each other $1. Cash. It doesn't crash. Why doesn't it? How is that possible? How can you possibly do 8 billion transactions in a second? This is ridiculous. Nothing can do that much. And it's like, when you think about it, though, it's like it's a ridiculous question to question how we're doing the 8 billion transactions per second, because think about it, cash, yeah, it's peer-to-peer. The only people involved in the transaction are the two people who are in the transaction. So there's no limit. Yeah. Imagine a society that is the whole solar system. There's billions, there's millions and billions of us all over the galaxy. And if we could somehow, time dilation, work it out so that on a specific point, we all did a transaction, it wouldn't matter. That also works. At no point does that stop working. That system scales. As far as I'm concerned, a scalable system is 0-1. It either scales or it doesn't. Blockchains don't scale. You could never do that on chain. You could never do it on layer 1. Yeah, there's just no way, because on a layer 1 transaction or on a sidechain transaction, everybody is involved in every transaction. I have to send that transaction across the network. Everybody has to process and validate it. We all have to put it into the block. And it's, even though I'm not involved in the transaction, everyone is involved in that transaction. That system doesn't and cannot scale. But with Omnia, with L2, with, like L2 is because Lightning 2. That's why it's called L2, it's Lightning 2. It's a peer-to-peer system, which means that there's no limit. It just works at any number of people, because the only people involved in the transaction are the two people who are involved in the transaction. And just to say, if you want to pass money through people, then that's kind of the same thing, isn't it? If I'm paying Neo and then Neo is paying Jazz, There's still only 3 of us involved in the transaction. Yeah, I pay Neo and Neo pays Jazz. And so it's like, that scales. Yeah, it may not scale. I mean, that scales. I'm going to say that scales as well. And that's how you can increase your reach. So this is what we want Omnia to be. This is what we are trying to do on Minima. You don't involve everybody in the transaction. You're not posting something that everybody on the network has to somehow see and do, because that doesn't scale. That's never going to work. Solana, I'm sorry. That's never going to happen. Sidechains, I'm sorry. I'm still reliant. And another feature that is almost unbelievable is it's private. Nobody knows. I don't know who's going on. I don't know what's going on over there. You don't know what's going over there. There's a level of privacy that you can almost barely understand. It's like, wow, there's all this stuff going on that I don't know what's going on. It's like Maxima chat. It's like, I don't even know who's talking to who on Maxima. I have no idea. Yeah, it's private, and it scales, and it's decentralized, and I don't need to ask anyone's permission to jump on and jump off. On the sidechain, I have to jump onto the sidechain. Somebody has to somehow convert whatever I've got over here and put it over onto this blockchain. And then if I want to leave, I've got to say, can I leave, please? Please, can I leave? And somebody does something and he converts my coins on that one onto that one. Permissioned. Nobody's involved. No permission is required in a channel transaction, in an Omnia transaction. Me and you can just do it. We're just doing cash. We're doing it. I'm paying you. You're paying me. Fantastic. Nobody needs to know. I don't need to ask anyone permission. That's why cash is king. And if you ask me, Omnia is the closest thing to cash in a digital sense. So this is why it matters. So now let's talk about the thinking that goes behind, how am I going to do this? Yeah. How am I going to somehow transpose this system that I've just explained to you with the 8 billion into some sort of digital system? Okay. How can that work? So let's start with an easier example. Okay. And let's do just one way. I'm going to do a one-directional channel. So I'm at home. Gardner's coming in. He's going to be working me for 30 days. All right. He's going to be working for me for 30 days and he wants to be paid every day. Yeah. I'm going to pay him every 24 hours. And then that will ensure that he comes back the next day. Okay. And I don't want to do a transaction every day. Can we do this off-chain? Can me and the gardener sort this out so that we don't have to post a transaction? So I could pay him every day. I could do a transaction every day. Fine. Pay 30 fees. It's a bit slow. It's a bit clunky if there's congestion. Can everybody do this? What if there's 1 million people with 1 million gardeners? It's like, that's not going to work. So how can me and this gardener sort this out? I'm paying him off-chain. All right, let's think about this. These are the machinations that you have to go through. These are the thought processes that go into coming up with the system. Now I'm like, I'll tell you what, why don't I write him a check? Some of you may not even know what a check is, I suppose, some of the younger kids here. And there used to be things you write and you sign, and then they can go to the bank and they can cash them. In blockchain terms, it means I'm going to give him a transaction that pays him. Let's say I pay him 10 minimum a day. Yeah, minimum is worth $10, where it should be. And I pay him 10 minimum a day. Yeah, $100. I pay him 10 minimum a day. So on the first day, I give him a transaction that pays him 10 minimum, and I sign it, and I give him the transaction, but I don't post it. He doesn't post it. He just has that transaction. I've given him the 10 minimum. He's got the valid transaction. He doesn't post it. He's like, okay, cool. He goes back. He comes back the next day. And the next day he does his work. And then at the end of the next day, I give him a 20 minimum transaction, and I sign it, and I give him the 20 minimum transaction. Now he's got 2 transactions, hasn't he? He's got the 10 minimum one and he's got the 20 minimum one. They both use the same bank account. They both use the same coin, the input. So he can only post one of them. He's going to post the 20. Yeah, he's not going to post the 10. He's going to post the 20. This goes on for 30 days. And at the end of it, I've given him 3,000 minimum. Yeah, because it's 30 times 10. So at the end of it, the last day, I give him the 3,000 minimum transaction, and I sign it, and he has that. He's happy, and he can post that transaction, and he gets paid. Everything worked, and it's totally fine. I wish. There's problems with that system. What's the problem with that system? The problem with that system is trust. The problem with that system is that what's to stop me from spending those coins before he publishes his transaction? So I've written him a transaction every day, and he can validate that transaction. He can look on chain. He can say, oh, yeah, it's valid. I can see the coins coming in. Yeah, I can see that this is a valid transaction. But before he posts it, I can spend those coins. Yeah, and you know how transactions work. They've got inputs and they've got outputs. They've got coins going in and they've got coins going out. And before he posts this transaction, I spend the coins, and then that transaction is worthless. I've nullified that transaction. So he has to trust me. Yeah. And just to say that this trust element is not something, I wouldn't do that. And maybe he does trust me. And maybe most of the time that goes on. But you don't want trust. Yeah. You want a system that doesn't involve trust. That would be objectively, that would be a better system if I didn't have to trust you, if I knew what you'd given me, like cash. And when I give you the cash, you've got the cash. I give you the £10 note, you've got the £10 note. You don't need to trust me. It's like he's giving me tenner. Yeah. And I suppose counterfeiting aside, which you can't do on a blockchain because I can verify them. So how could we somehow fix this trust issue? How can I pay him in a way off chain that I can't then screw him over? Okay, how about this? What if I send the 3,000 minima to a contract, to a multi-sig, and the contract multi-sig says return signed by 2 of 2. And what it says is both of you, me and the gardener, have to sign to spend from that account. Okay, so I've got my 3,000 minima, and I send it to this multi-sig, and the multi-sig says both of you, you and the gardener, need to sign to spend from that. Already there's an issue, because what happens if he then refuses to sign anything and he blackmails me? I've sent money to this account, and he says, "No, I'm not signing anything now unless you give me half. Otherwise, the money's stuck there." So it's like, all right, okay, fine. So what I'm going to do is I'm going to make a contract which says, in 35 days, if I sign only me, I can spend those coins. In 35 days, so in 35 days, I get this money back, whatever happens, if it hasn't been spent in 35 days. Or, this is the contract, if signed by me, and the time is 35 days in the future, I can spend it. Or, we both need to sign. Same as before, we both need to sign. Very simple little contract. It's got a little time lock which says, I can't touch the funds myself for 35 days, and otherwise we both need to agree. Okay. I then send the 3,000 minima to that contract. At the end of the first day, what do? At the end of the first day, I write him a transaction which pays him 10 minima, and I sign it. And then I give him the transaction. That's currently not a valid transaction because it needs both of our signatures. So I write him the transaction, I pay him the 10 minima, and I sign it. I then give him the transaction. He signs it, doesn't give it to me. He now has a valid transaction that he can post for the next 35 days because I can't do anything for 35 days. He has a transaction that is valid, that is signed by both of us, that he can post at any time and get 10 minima. And I can't do anything about it. It's like, the next day he comes back to work in the evening. What do? I write him another transaction for 20 minima and I sign it and I give it to him. He signs it, doesn't give it to me. He now has another valid transaction that he could post at any time that gives him 20 minima, and there's nothing I can do to stop him. He doesn't have to trust me. He knows that there's nothing I can do for 35 days. Onwards. On the 30th day, I write him a transaction that pays him 3,000 minima, and I sign it, and I give it to him. He signs it. He posts it. Boom. I've just paid him every day. There's no chance that I can, muck him about. If he doesn't come to work or he doesn't do anything, he either has the 20 minimum one that I gave him on the second day, or I pay him every day. But if he doesn't come, I don't write him a new one. I don't write him a new transaction. And if he just disappears the minute I start this whole process, I get all the money back in 35 days anyway. So I don't have to trust him. So now we've got a unidirectional, a one-way payment channel. Now, I was paying him every day. He says, no, I like to be paid every hour. I'm like, all right, that's fine. It doesn't cost me anything. I don't need to post this on chain. I'm just writing a transaction and signing it. He's like, I only paid every minute. No problem. No problem. So what we're basically doing is we're doing transactions as fast as we want. Yeah. He doesn't need to be paid every, but he says, I like to be paid real time. I'm being paid in real time per second. It's like, no problem. That's fine. It doesn't cost us anything. I just write you a transaction and sign it. You sign it. Don't give it back to me. We've now got a real-time payment channel where neither of us has to trust the other person. And I can pay you to the nearest second. You work, I'll pay you to the nearest second. And those, just to say, are valid transactions. They're not like fluffy stuff. That is a valid transaction that he can post at any time and get his money. It is a valid, minimum transaction. It's not something else. I don't need to trust somebody else to post it onto something. He can post it. It's permissionless. He doesn't need to ask anybody anything. It's just a normal transaction. He's posting it. Okay, that works. That's a one-way channel. Pretty useful. Yeah. You see how you have to think about this. It's like, how can if I do this, okay. Now we want to do, and obviously a one-way channel is nice. If I'm paying you, that's great. But that ends at some point. At some point, all the money is going to be given to him. At some point, I'm going to have used the services enough that I don't have any more money to give you. I only put 3,000 minimum into that account, into that coin that I'm using in these transactions. So after I've spent 3,000 minimum with you, we have to close that channel. That's the usefulness. I suppose what you could say is I could have one with you and you could have one with me. Yeah, but at some point when one of us has used up all of his capital, all of the money that I thought I was going to spend with you, that's it. The channel is now useless. Let's close it. Our transaction is completed. Fantastic. A bidirectional channel, a two-way channel would be much more useful, exponentially more useful. If I can pay you, but then you can pay me back, there's almost no limit to how long that channel could last. I like to think of it as I'm Starbucks, they're an employee. I can pay them at the end of the month, but they may want to spend money. They may want to buy a coffee. They may want to buy a sandwich at the weekend or whatever, maybe McDonald's, and they want to eat burgers. It's pretty hard for the price to beat a McDonald's. So, if you have a business and a worker and I'm paying the worker and he then wants to spend the money back with me, a bidirectional channel would be pretty useful. Yeah. I'm not saying they would spend a sizable amount of their money, but I don't know, they might. If you're an Amazon worker, who doesn't buy stuff from Amazon? Basically everything that isn't fresh, where are you going to buy it? That could be a sizable amount of your money. That channel could just be like, I pay you, you spend with me. I pay you, you spend with me. I pay you, you spend with me. That could last forever. That's how we're going to do that. So I'll have a think about it. Let's think about it. It's like, okay, so in the last example where we were doing the one-way system, I gave him the transaction, but he didn't give it back to me. Yeah. Because then I could have posted it. But let's run through that. Okay. Let's say we do the same thing. I'm going to send 3,000 minima to an address, which again says, you need to be signed by both me and you. And before I publish it, because if I publish that, I can't put the time limit in. If I say, look, after 35 days, if we haven't done anything, I can collect it. Yeah, I can't do that again now, can I? Because then he's going to be sitting there thinking, well, in 35 days, if the channel's still open, you'll close it. We want this channel to last forever. I don't want there to be a timed get out clause for you. And I'm like, okay. The reason we had that get out clause was that if you went unresponsive, I still need to be able to get out permissionless. Is that possible? Yes, it is possible. How would you do that? Well, stay with me. This is a slightly complicated bit here. I can spend a coin that hasn't been made yet. I can write a transaction that spends something that hasn't even been put on the blockchain yet. So what I would do is I would create, I would get my 3,000 minima, and I would send it to this coin, and I would get that transaction ready, but I wouldn't sign it. I wouldn't sign it yet. Okay, I'm sending it to the multi-sig. I'm sending it to this contract that says both of you need to sign. For the coins to be spent. And then what I do is before I post that transaction, I get us to sign a transaction that pays me back. So that once I've posted it, if you disappear, I can post this transaction to get the money back. Now we work the same way. I want to pay you 10 minima. I give you 10 minima. I write a new transaction that gives me, if I put 3,000 into it, so I'm getting 2,990 and you're getting 10 signed. You sign it. We both have that transaction. Now I'm going to pay you 100 minima. So there's now 2,890 going to me and 110 going to you. I could have picked easier numbers. Anyway, there's two outputs to this transaction. One's to me and one's to you. And we can just shuffle those around. And we both have a copy of that transaction. And we can both publish it at any time and just close the channel. But we don't have to. We can just keep going. Again, it would be nice if that worked, but it doesn't. That doesn't work because, let's say at the beginning, I had all the money. At the beginning, I put my money in. And then after 2 or 3 months of us doing this channel, you have all the money. Yeah, because I've sent all the money to you and you don't want to work for me anymore. So it's like, okay, now you've got that. What stops me sending an earlier transaction? Yeah. You want to post the last transaction. And I'm like, oh, if you pass the last if you post the last transaction, you're going to get all the money. But I've got from 2 months ago, a signed transaction that gives me all the money. So I'm going to try and post that, aren't I? Of course, I'm going to try that. And so actually the only tricky bit, the bit that matters is me and you in the channel. How do I make sure that only the last signed transaction actually gets on chain? When we were doing the one-way channel, the way we enforce that is by not giving me a copy of the fully signed transaction. That's how we did it in the previous example with the one-way channel. He was the only one that had the full transaction, so he was obviously only going to post the one at the end where he got all the money. So that is how we enforced that only the last transaction was posted. Now that we're doing a bidirectional channel, we keep writing new transactions. We keep doing new steps. I pay you, you pay me, I pay you, I pay me. But each of those is a valid transaction. Each of those could be posted. And what Omnia does, what L2 does, is how do I make sure that only the last transaction gets on chain? I've got all these valid signed transactions. How do I make sure that only the last transaction gets on chain and not any of the previous ones? That's the trick. That's the thing that we're trying to do. I'm going to share my screen now because I want you to see. Yeah, I'm sharing screens, screen one. Here we go. Go live. Okay. He's doing it. He's done it. Okay. So, Neo, you can see this, yeah? You can see the screen in front of you.
Yeah, I've got it.
Fantastic. This right here, that's the flux capacitor. That's the bit that makes L2 possible. That's all it is. Very simple contract. And what we're trying to do is we're trying to make sure that only the last transaction gets on the chain and none of the previous transactions can be posted. Not a simple, you're like, it's impossible. If I've got a previous transaction, obviously I can post it. Correct. So we're going to have to be a little bit clever in how we make these transactions. So what the contract does here, this is the L2 contract. That's all it is. This is the bit that does the clever bit. This is the bit that makes everything possible. When you do a transaction in your Omnia channel, there's a sequence number. This is the first transaction. This is the second transaction. This is the third transaction. Sequence number. Okay. And in minima, on this example, it doesn't have to be, you're storing that in state variable 99. Okay, I excuse the non-techies here. This is really for the devs, but I want you to see that this is not a complicated multi-page document. This is all it does. So I'm storing the sequence number in state variable 99. Okay, so I have my new transaction, which has state variable +1, and I have my old transaction, which has the old state variable. This will be 4, this will be 3, this will be 7, this will be 6. Yeah, the previous transaction was 6, this will be 7. What it says is, if the state, whenever I'm doing an update, whenever I'm doing an Omnia channel update, I actually create two transactions, not just one transaction, two transactions. One of them is called the settlement transaction, and one of them is called the update transaction. The settlement transaction pays out. The settlement transaction basically closes the channel. It's like, we're settling up, let's do it. And the update transaction increases the sequence number by 1 and says, no, we've now done 10 transactions. No, we've now done 11 transactions. No, we've now done 12 transactions. And the really important bit is this bit. If coinage greater than 256, what does that do? So what this is saying is, if the sequence number in this transaction is equal to the old sequence number, if this is sequence number 9 and the previous transaction was 9, and the coin is 4 hours old, and this has been on chain for 4 hours, 5 hours, whatever it is, and we've both signed it, then I can spend it. If the sequence number is the same as the old one, so if I'm on update 5, I need settlement 5. If I'm on update 6, I need settlement 6. And the coin, which is on chain, is 4 hours old, I can spend it. Or else if the sequence number is more than the previous transaction, if I've got an update from if I've got a greater number in the sequence, this is 1000th transaction. You've posted the number 5 transaction, which you really, where you had a lot of money. I'm posting the 1000 one, which is the one that I want. Yeah, the 1000th transaction. And it's signed by both of us. No time delay. There's no time delay on this bit, on the update. Then return true. All right. What does that do? So this is the crux. This is how it works. It basically says every time I want to update the channel, I create two transactions. I create the settlement and I create the update. I can always post a later update without delay. Yeah. So if you have to post an update, the update points to itself. The update just points to this contract again with a higher sequence number. And either of us, we have two transactions we have two valid signed transactions every time we do an update. And if I publish an update, which is the one where my settlement is better for me, you can always publish a later update because you're not allowed to settle for 4 hours. You're not allowed to collect the money from that update until 4 hours is up. And in fact, if we look at, I'm now going to go even lower. Yeah, that's all it is, gents and ladies. That's the settlement transaction, and that's the update transaction. That's the amount of code that's required that I'm talking about. When I want to do an Omnia update, this is in the demo that I will take you through in a second. That's all that we're doing. And so what we've basically done is we've said, let's go back to, these are the docs as well, kids, that is in the minima, local, you've got local things. What you've done is you've said, we're going ahead, we're doing it, and basically at no stage can you try and publish a previous transaction without me being able to publish a later transaction. And then you have to, because then I publish my one, you don't have one after that. I published the last one. There is no update. You need to have state, the state needs to be greater. The sequence number needs to be greater than the previous sequence number. So I can't publish another one. And then after 4 hours, I can settle and I can take my money. A very, very clever little bit of code. And all it does is enforces the fact that you have to spend, that this enforces, no matter how many, what mucking about is going on. Yeah. And just to say, you don't need 2 people in this. There could be 5 people in this. There could be 7 people. Let's keep it simple. It's 2 people. Whatever's going on, I always get the final state. I always get the final state in the transaction, which is really, really cool. And just to say, now imagine me and you, right, shall I go to the Thundercats? Right, I'm going to go to Thundercats. This is another one for you devs. This is the DAF I've just posted in dev chat. And what I've done is I've written a complete sequence that allows you to do an Omnia channel. So what am I going to do? First, I'm going to create So just follow me. This will take 2 or 3 minutes, and then I'll show you. So first, the hardest bit of Omnia is setting it up, actually, because we both need to be involved. We both need to put money in. We both need to be signing transactions. If only there was some way that Minima users could communicate with each other. If only there was, because I need to communicate with you, because with that, we need to be sending transactions backwards and forwards, and we need to be signing them, and then I need to give it to you, and then you need to give it back to me. There is a way. It's called Maxima. Yeah, there is a way of doing it. And just to explain that, although this is the Omnia bit, yeah, if I show you here, look, if I show you here, it's like literally that's the difficult bit of code. The rest of it is posting, signing some stuff. There's nothing complicated here. Yeah, this is basic stuff. Yeah, those two are the bits. That doesn't mean you can write any mini dApp you like. Yeah, you still need to write all the gamma. You still need to write a nice mini dApp, and it needs to look nice. And you need to have communication channels, and you need, all of that. That's separate, though. That's what software, that's what coders live for. That's what we're doing. But the Omnia bit is simple. The Omnia bit is actually not complicated at all. So when you start the app, open up your console window, your console logs, and you'll say, right, I'm going to create a funding transaction. All right. So what I've done is I've sent 20 minima. Yeah, I've sent 20 minima to the funding, to the 2 of 2. I've sent 20 minima to the 2 of 2 contract. I haven't posted it. I've just created the transaction, but I haven't posted it yet. Then what I'm going to do is I'm going to say, right, create the trigger. It's called the trigger. This is what we refer to it, which is actually update 0. Okay, this is the first thing. I'm going to create the trigger. Boom. All right, I've now created the trigger. What that does is it spends the fund transaction. I haven't posted the funding. It's not on chain, but I've now created another transaction that spends that, even though it hasn't been done. It uses something called a floating coin. Very simple. I'll show you here. Yeah, floating, true. Yeah, you can make coins. And what that does is that in UTXO systems, every coin has a coin ID. And you say, this transaction's got this coin, and you specify the coin ID, which means only one specific coin can be used. The trick requires something known as a floating coin, which says, I'm going to give you the address and the amount and the token ID, and you can use any coin that has that address, that amount, and that token ID. So I don't specify a coin ID, which is how I can create this other transaction that spends this one, even though I don't really know the coin ID. I say, well, look, I know the address that I'm sending it to, I know the amount that I'm sending, and I know the token ID. I can put that as an input to this transaction without specifying the coin ID, because I say, just find a coin that has this address, this amount, and this token. You can put it into this transaction. So that's the bit you need. That's the bit that Bitcoin doesn't have. Yeah, that's the single bit that Bitcoin lacks, this ability to have a floating coin. So I've created the funding and I've created the trigger, but I haven't posted either of them. I've still got them. They're just in memory. And now that's the update 0. And now I'm going to create the settlement transaction. Settlement transaction created. All right. So I've got 3 transactions now, and I haven't posted any of them. I've got the funding, I've got the update, and I've got the settlement for 0. Yeah, settlement 0 can spend update 0. And now I'm going to go back again. Trust. I don't want to. If I sign the funding and post it before he signed the update, he might post that, and then I won't have the transaction required to spend that. You got to. If you take it slow, if you work backwards, then at no point there's no trust here. Yeah. I'm going to sign the settlement, the last transaction in the sequence, the C. I'll press sign settle, and boom. I've signed the settlement. So the last transaction is currently valid. It spends the update, which I haven't signed, and which spends the funding, which I haven't signed or posted. I'm now going to sign the trigger transaction. Okay, so I press that, waiting, and tick. Trigger transaction sign. I've now got a funding transaction that I haven't signed and posted. An update, which is ready, signed to post, but I don't have that to spend, and a settlement, which is ready to go, post, but I haven't posted it. Now I'm going to sign and post the funding transaction. Let's have a look here. All right, boom. I'm looking at. I've got Minima open. I've got triple screen set up here. I've got Minima running here, my nice little solo network, and I can see. Yeah, try and mine the transaction. You spent coin. You unspent coin. So what does this mean? So list funding coins. Boom. So there's now one coin with 20 minima, which says both of you need to sign to spend this coin. I've got 20 minutes, it's age 1. Yeah, it's only I've just got it into the chain. Both of us need to sign. And I have a transaction that spends it. I have the trigger. I have the update 0 that I could post right now if I wanted to, but I don't want to. And I've got the settlement. So either of us can close this channel right now. There's no problem. Either of us permissionlessly can close this channel. So now what I'm going to do, let's do a transaction. Let's do an Omnia transaction. So sequence 1, yeah? The first one was sequence 0, yeah? The first coin was sequence 0. So let's say I'm going to send him, user 1 is going to send user 2 1 minima. That means user 1 will be on 9 and user 2 will be on 11. Update my Omnia channel. Update transaction 1 created, settlement transaction 1 created, the settlement is now signed, and the update is signed. So what's happened? So now I have 2 transactions. I still have my trigger. Yeah, I've got my trigger, but I've now got another set of 2 transactions where I'm paying you 1 and you're paying me 1. Like, that's a valid transaction. I've just done it. I didn't have to go, I haven't touched on chain. Nobody knows I've done it. I haven't put stress on anything. Yeah, this is just me and you transacting with each other. Now I'm going to pay you again. I'm going to do 7. So I'm going to give you 2, 13, update Omnia channel. All right, now we've got a second transaction. So these are fully valid transactions. This is not just like numbers in a database. These are fully signed transactions that either of us could post at any point. Yes, thank you. These are valid transactions that either of us could post. I could do this. Now I'm going to, this is interesting. I'm going to give it back. So now I'm actually going to give you the money back because I wanted to buy a burger. So you're going to have 13 and I'm going to have 7. There we go. Update transaction 3. These are transactions, even though they're not touching the chain. Yeah, that's right. These are transactions. Right, that's it. We've been doing this for months. I'm sick of doing this. Let's close the channel. Yeah. I mean, you probably wouldn't, you really wouldn't close the channel unless you had to. Why close it? Just keep it open because I can bounce through you. That's for another discussion. We're doing 1-to-1 at the moment, but as I've told you on many occasions, I can bounce through you. Yeah, I can pay you and you can pay him in a clever way, which means that either everybody get paid or nobody gets paid. Yeah, so once you have the 1-to-1 is the important one, and then I can do the 1-to-1 to, I can bounce through you. Anyway, we're going to close this channel. I don't want to work for McDonald's anymore. I'm getting freckles. I'm getting spots, right? Let's post the trigger. So all we've got currently, the only thing that is on chain is the funding transaction. There it is, age 9. Let's post the trigger. Boom. I'm looking. There it is. Async transaction mine, you spent coin, da-da-da-da-da. What does that mean? That means the funding coin's gone. That's right. You spent the funding coin. I spent it in the trigger transaction. And now there's an L2 coin. Woo! Yeah, that was the trigger. That was the update 0. Stay with me. Yeah. We had the funding. I've now spent the update 0. I've sent the first transaction in that sequence. What does this mean now? What this means is that when the timer runs out, in the demo, I use 10 blocks. I can't be bothered to wait 4 hours. Yeah. So in the timer, I say 10 blocks. Yeah. If you look, I'll see. Where is it? Here it is. Yeah, see the L2 script. I use greater than 10. I say, look, if the coin is older than 10, you can settle. That's just because I can't be bothered to wait. This is a demo, blah, blah, blah. So I posted the trigger. It's sitting here. Yeah, that's the state variable. State variable 99. So we're at update 0, which means that in 10 blocks, you will be able to post settlement 0. In 10 blocks, if I ever get to 10 blocks, let's have a look. Let's the L2 coin. It's 3 coins old. Imagine you have to wait 4 hours. All right, imagine that needs to be a big number. But when that gets to 10, I can post settlement 0. Remember, it says if coin age greater than something and the same number as the settlement and the update, then I can post it. But what am I going to do? I'm going to post the last update we did, which I don't have to wait for. Yeah, there's no timer on that. I can post the latest update whenever I want. There's no delay. Okay. All right. So I'm going to go post update. Bang. There it is. Async transaction mined. So what have I done now? The old L2 contract had 0 as its state variable. The new L2 contract, let's have a look. Come on. Get in the chain. Da-da-da-da. There it is. Data type 3. All right. So now what I've got is I've got an update transaction, which is sequence number 3. And just to say, if you had a later one, if I was trying to be shifty, and it's like, that's the one where I have the most money, and you had a sequence number 27, posting your latest update until we get to the final update. And now I don't have a new update. I don't have a later update. I'm just waiting for 10 blocks. I'm waiting for this age 1. I'm waiting for age to get to 10, and then I can post my settlement transaction and everybody gets paid. This ensures that neither of us has to trust the other. Now, the astute among you will be saying, oh my God, this is a nightmare. I got to post that, then I'm going to post the trigger, then I'm going to post the update, then I'm going to post the settlement. No, you don't. This ensures that neither of us can screw around with the other. This ensures that both of us trust each other. In fact, right. So I'll wait. I'll wait until we get until we get to age 10. Then I'll print the settlement. Then I'll be done. Knowing that neither of us can muck about with the other, knowing that whatever happens, at the end of this little sequence of transaction, I'm going to get 7 and you're going to get 13. What could we do? At the beginning of this, all that was available was the funding transaction. All that was available was the one coin that we used to start this process. Then I posted the trigger, which was the update 0. Then I posted the latest update. And now I'm going to post the last settlement transaction. So there's like 3 transactions I've had to post to get my 7 and your 13 in a way that is unscrewable. Nobody can muck about with that. Knowing that we both know that, what could I do? I can say, hey, man, why don't we just spend the funding transaction, create a new transaction that sends me 7 and you 13 and we'll sign it. The whole thing will be over in 3 blocks. 3 minutes from now, we can both have our money and we can both go our separate ways. And that's what you do. And it's an important thing to understand, because what it's saying is that you can't screw me over and I can't screw you over. So we may as well play ball with each other and just close the channel correctly. And then neither of us has to wait. There's no time delay. There's no nothing. If you muck about, if you try and screw me, yes, I will have to post the latest update, and then you can post yours and I'll post mine, and then I'll post the settlement. The end result is the same for both of us, just that you've had to spend a transaction. You've had to pay a fee. So why would you do that when it's the same? And you've made me wait 4 hours. I agree. That is a problem. That's not nothing. But you have to do a transaction. You've made me wait 4 hours. The end result was the same. Or we can close it off now. Both of us can just walk away with our money in 3 minutes. List out 2 coins. Age 9. Okay. It's got to be 10 or more. And then I can post the settlement transaction. And then both of us can be paid. And so what Omnia does is, and again, I'm showing you this, but you don't know that I'm doing this. None of this is going on chain. All of this is being communicated between me and in this demo, ladies and gentlemen, when you're doing it, I've done all the coins, I'm doing it to myself, obviously, but I'm communicating with someone over Maxima and doing this. Nobody knows that this is going on. This is completely private. There's no record of this anywhere. You wouldn't have a record. Unless one of us, could keep that data and then expose it, but most people probably want probably want their own privacy. They don't want to share that information. Let's start to 11. I'm going to post a settlement transaction. Post a settle, new unspent coin. All right. That totally worked. So then I'm going to turn this off. What have we done? We did the whole process from beginning to end. I created a funding transaction. I didn't post it. I created a settlement transaction that spent the funding and didn't post it. I created an update transaction that spent the funding, and didn't post it, and then the settlement that spent the update but didn't spend it. Then I go back, I sign, I don't post, I sign and post, boom, we're ready. The setup is the only minorly tricky bit. You have to get that right. You have to set up the channel in the correct way. And then we did 3 transactions. We did some transactions. We sent each other money, and then we closed the channel. And we did it in the annoying way. We did it the way that means that neither of us can screw each other over. I could have just spent the funding transaction, with myself. And I could have just said, nah, it's all right. I know that neither of us can run away with this. And so I'll just spend the money and give it to us. That's Omnia. Right, wait a sec. Let me go back here. And then let me stop streaming. There I am. Okay. So that was a little demo. I put the demo mini dApp into the dev chat, and you can have a look at that. And I'll take you through that. If anybody has questions about that, ask me in the dev chat. We can talk about it. But that's it. That's Omnia. It doesn't need anything else. What I will say, which is quite important, money, payment, that's the 51% attack. That's the use case. There is no other use case that will ever be more than money, than cash, than payment, one to one. There are lots of other use cases. Bitcoin doesn't do that, does it? Bitcoin only does money. And it works. People love that. Paying people is the number one use case. There is no other use case that is more important than paying someone. DEXs, NFTs, meme coins, whatever the hell it is, the monkey, money, cash will always be the greatest use case. But it might be like 51%. There's still 49% of that space that I feel nobody touches. And this is what is important about the way that Minima does it. Firstly, you need a UTXO system to get this right. On Ethereum, when you sign a transaction, you need to have the nonce in the transaction, which means that you can't actually sign. It doesn't work. This only works on UTXO systems. The Lightning, the L2 only works on UTXO systems. It's only for us. Yeah, for Minima, for Bitcoin. Maybe for Cardano, although it's not quite there. And the scripting they have is so simple. I've said this as well. The scripting they have on Bitcoin doesn't allow them to do other things, cooler things. Whereas on Minima, our scripting is actually really cool. I'm serious when I say it is Turing complete. Yeah, it is Turing complete because there is a definition of what it means to be Turing complete. Yeah, Alan Turing came up with that. And you can say you are Turing complete if you can write a Turing machine in your scripting. Yeah, because Alan came up with a machine called a Turing machine, and he said, look, the ticker tape, and he could read a symbol or write a symbol, and he could move the ticker tape left or right. And he proved mathematically that if you gave me this machine, the ticker tape machine, I can process anything. I am Turing complete. There's no function I cannot run on this ticker tape system where I can read left and right. It may not be fast. It may not be, it may not be fast, frankly, but I can write any function in the ticker tape machine. And what's really interesting about that is he said, so as long as your system allows you to simulate a ticker tape machine, you must also be Turing complete, because you could just simulate the ticker tape machine and then you can do everything. I don't simulate a ticker tape machine, but the fact that I can means that I am Turing complete. So Minima is Turing complete. And what Omnia allows us to do is, instead of just payments, which is cool, which is big, which is the case, I agree, yeah. The complexity is going to be in routing, about how many people do I have to bounce through to pay this person? That is a separate problem. That is a network topology issue. That is, a traveling salesman. There's so many other things that are going on when you're trying to pay through multiple people that have nothing to do with the smart contract side of it. I have to find the person. I have to find all the people in between the people I'm sending it to. Each of us has to communicate in some onion routing where you peel away the onion, but nobody knows who they're doing. Well, there's lots of other stuff that you can do just in the payment stuff. But what Omnia and Minima allows us to do is it allows us to do any sequence of transactions, not just payment. So I don't know if any of you have seen the Lotto game. Yeah, very simple. I mean, it's boring, exciting, you're gambling, but that is a sequence of transactions. It's slow, it's clunky, it's heavy, it runs on layer one. I do a transaction where I put my random number, you spend that and put your money into it, and you put the hash of your number, then I reveal the hash of my number, then we hash another transaction, then we hash those two values, and if it's less than this, I win, and if it's more than this, you win. Very simple game that runs on layer one, Lotto. Perfect for Omnia. I can take any sequence of transactions I want and I can just lift them off chain, and I can use that clever little flux capacitor. And basically, I write the transaction, yeah, and the settlement transaction basically points to that contract with the correct state variables, and I can do anything. Oh, here he comes. And I can do anything. It doesn't just have to be payment. It can be a game. It can be chess. It could be whatever you want. Smart contract backed. And what Omnia means is that neither of us can screw the one over. Yeah, I don't need to post the transaction on chain. I can just do it and give it to you, and then you do it and you give it to me, and then I do it and I give it to you. And Omnia ensures that the last transaction is the one that gets on chain. And if either of us tries to be funny, we just jump down on chain and then we just resolve it. We resolve it as normal without having to go on Omnia. But knowing that, both of us knowing that, means that we don't do that. Will, you've popped up on stage. Is there a question you'd like to ask?
Yeah, hello, that's very cool. Can you hear me okay?
Fine, sir.
Okay, quite exciting. I have a few thoughts. One is like, and maybe you can disabuse me of them if I'm wrong.
Disabuse you, all right?
Yeah. One is like, so this is only really relevant in multi-shot interactions. Is that right? So you talk about payments, but if I imagine lots of payments that happen on Bitcoin, for example, lots of payments that happen in crypto land happen between two people who are interacting today but aren't going to interact tomorrow. So most payments aren't payments to your gardener. They're payments to, I don't know, a guy that you're buying a t-shirt from.
Steak and Shack in America, who's just enabled Lightning across the whole thing.
Okay, yeah.
If you're saying I don't have to open a channel with everyone that I want to interact with. What I'm just showing is that if I can do two people, I can do three or four. If I can hop between two of us, then it's perfectly possible for me to hop through someone to somebody else. And so what you want to do is, if I've got a channel with you, Will, and you've got a channel with Neo, can I pay Neo? Yeah. Well, who else have you got a channel with? And can I then pay someone that they've got a channel with? The degrees of freedom, what is it, 6? As soon as you've got 6 channels deep, you can pay anyone in the world.
So is it feasible to imagine? Is it feasible to imagine a point of technological development of Omnia whereby it's kind of integrated rather than it being a mini DApp? It's like, it's basically the same as if I've got 20 Maxima contacts, they're also all my L2 contacts.
So you took the words out of my mouth, sir. What I was going to say is, wouldn't it be nice if every Maxima contact you have, it just automatically started a channel?
Yeah.
And then the truth is that it's more like Chatter. Yeah, Chatter bounces Maxima messages through your Max contacts and their Max contacts. And what it would mean is that anybody I see on my feed, I can pay over Lightning because I know that there is a route between us. So if when you added a Maxima contact, it said, hey, would you like to open a channel with them? Yeah, all right. And then if I had 20 channels and then admittedly, the amount of capital you put in the channel matters. Yeah, that is something that has to be brought up. You need to put in money into the channel, and I can't send you 1,000 minima if I've only started a channel with you that's got 100 minima. But for tipping, for all that sort of stuff, then it's totally fine. For large, this was a problem with Bitcoin when the Lightning Network started. And it's funny because I think someone in dev chat was going, Lightning hasn't really worked. And I kind of agree. It hasn't really taken over the world. But slowly, last week, Steak and Shack, or whatever it's called, the burger place in America, the big burger place, has enabled Lightning payments across its 5,000, 10,000 different shops. And it works seamlessly. And it's fine. These things take time. And what's important and what's interesting is that at the beginning, everyone put in £100 into their channels. Now you can almost send half a Bitcoin, 50 grand. Yeah, the channels get bigger. And what's also very nice is that it is an incentive compatible system. Why would I put loads of money in? Because I'll pay you to route my traffic. Why would I make a channel with someone with more money than I think I'm going to spend with them? Because you'll get paid. The more traffic you route, the more money you make. So it's incentive compatible. So Yes, absolutely. Clearly, I'm not just going to be paying people one-on-one when I start a channel with them. I want to be paying people, 4 or 5 people away from me. And we've seen that is perfectly possible. But like I said, that's a traveling salesman problem. That's a network topology problem. These are problems that, many, many books about computer science have been written. How do I find the root? But what I will say, though, is that purely on the one-to-one basis, payments is one thing. It's big. You want a robust L2 Omnia network that allows me to tip people on Vox. Yeah, so that I can tip anybody on Vox that I want to with money instantly, and they've got the money and all the channels rebalance. And it's like, that's great. But if I wanted to sit down at a table with 4 participants, because you can have more than 2 participants in an Omnia channel, there's nothing to stop you having 5 people in the channel. Yeah, you could sit down at a table, 1 transaction. You sit down at the table, all 5 of you. And then we can play poker with each other. Smart contract-backed poker. Decentralized, trustless, provably secure and fair. I could play poker with these people, and we could just be handing transactions around the table. And then to stand up, to leave the table, takes 1 transaction. But I bet, I call, I raise, I draw a card, each of those is another transaction. Each of those is another sequence in the Omnia sequence. We're talking 20,000, 30,000 transactions required for our evening of poker. No problem. 1 transaction to sit down, 1 transaction to stand up, and all of it is secure, trustless. That, I think, is where. So as I had a little chat about this with somebody else, and that's what I'm working on. That's what I'm trying to do for minimum. I'm trying to get to poker. I've done a little demo. I'm going to do the payment between the 2. I'm not sure I'm going to spend years. We're talking 20 to 30, 20 to 50 of the smartest coders, have been working on Lightning for the last 10 years to give us the Lightning network. And they didn't spend 10 years writing the contracts. They spent 10 years trying to come up with the QR code reader and the interface and the way that I can scan a network breadth first, depth. How do I know where people are? There's a lot of other areas of computer science that are involved if you're trying to do a payment network that have nothing to do with the blockchain bit. The blockchain bit was basically done 7 years ago, and now they've been working on other bits of this, fallback mechanisms, et cetera, and that's great, and that's fine, and I want that. I'd like someone else to have a pop at that. What I want to do is I want to do something that you can't do on Bitcoin. I want to do something that I don't see anywhere else. I don't see this anywhere. I don't see trustless Lightning casinos where everything is provably secure, with the whole game, the craps, the blackjack, the roulette, the poker, the fruit machines is mathematically backed in a way that I know doesn't matter where I am, doesn't matter who I'm gambling with. It's fair. It's secure. I can lose. That's fine if I lose, but you can't cheat me. And that's where I think, Minima really has a chance of doing something cool, because of the power of our scripting language, the fact that we use Omnia, the fact that because you need to be running a full node for this to work. If you don't run a full node, then you don't know whether I've posted a previous transaction, do you? This all on Minima, this all works. It's like we take it for granted that you're all running full nodes. I see every transaction that goes. Yeah, they call them watchtowers on Bitcoin, because if I'm in a Lightning transaction with somebody, I don't run a full node on Bitcoin. I mean, I do, but most people don't run a Bitcoin full node. And so they can't tell if the other person's trying to screw them. And so they have a watchtower. Now, when they know the person's trying to screw them, they can post the latest update and and they can get the money, and that's fine. But I'm just saying, you need to trust the watchtower. Seems pretty, it's sort of like, I've done all this work to make it trustless, but I now need to trust this guy to make sure that they're not doing something. Whereas on Minima, you all run a full node. So you don't need to trust anybody. You're running it. You can tell you're doing it. You don't need anyone. Finally, I can operate, peer-to-peer in a trustless, decentralized, permissionless way. Neil, I haven't left much time. Does anybody else have? Sorry, I've just noticed the time. I hope that wasn't too complicated. I hope you got to see what we're talking about. I'm trying to show you how you think about this problem. I'm trying to show you that it's not weird rocket science. There's a couple of simple contracts that have to be set up in a slightly, you have to take care when you're setting this stuff up, and then it's beautiful. Then it works. Then you can do this stuff. Joshua's little game, the tic-tac. Somebody. I'll tell you what. A good example. I was thinking if I wanted to give a challenge, I challenge you to write tic-tac-toe. Yeah, noughts and crosses. Write me noughts and crosses. Omnia cross, whatever they are. Yeah, that would be a good one. I mean, could you write chess? Yeah, you could write chess. Could you write backgammon? Could you write, these games? Because trustless gambling is not nothing. That's a big thing. Yeah, when I'm using a website, all I see is websites that accept payments. They accept crypto. Yeah, it's like, yeah, we're a crypto casino. It's like, you're not a crypto casino. I'm still using a centralized game engine, and you're just letting me pay in crypto. I want the game to be smart contract back. I want that to be the bit. That's the bit that matters to me. That you're not looking at the cards and telling people what they are, which every single one can do. I don't want to have to trust you. Yeah, I want this to be the game that I could play on the dark web. You have to assume. I mean, the way I think about it is this: it's like, it is my duty to try and take your money. I'm going to say that again. It's not a nasty thing. It's like, if I can, I will. And what that forces you to do is to ensure that I can't. That's what you want. You want a system where it's like, clearly, if I can take all the money, I'll take it. Yeah, this is a rational actor. If I've got a big pot of gold over here and I can take it and nobody can stop me, why wouldn't I take it? I agree. So we've got to come up with systems that mean that you can't take the money. That's what we want. Trustless. That's what we're trying to build here. And that's what I think we can do with Minima.
Okay.
Does anybody else have? Yeah.
Well,
does anybody else have any questions?
That was quite fantastic, to be honest, I must say.
Did you get it, Neo? Did you follow? Did you follow that?
I followed.
All right. Then we have succeeded. Then we have done the right thing.
There is a question in the chat. I didn't quite understand it, from Zubi Zaretta, who asks, who set the timer for Omnia? And in the machine economy, where will optimization be highly effective, L1 or L2 or both? And how will this be achieved?
Clearly in the machine economy, which is another thing that you're right. That's the machine economy only works if we do Omnia. Yeah. We're talking billions of devices. Yeah. We need something where everybody can pay everybody and nobody knows that they're all paying each other. In the machine economy, so the classic example of the machine economy is you have the three sensors. You have the Wi-Fi router, you have the fire sensor, and you have the water sensor. And the water sensor wants to talk to the fire sensor, and the fire sensor says it's going to cost you 1/100th of a penny, and I'll tell you the date, I'll tell you the stuff. And it's like, fine. So frankly, when it comes to machine, it's probably payment. Yeah, the machines will pay each other to do what they're each good at, which would be a really efficient way of doing it. Yeah, you'd get a much, much more efficient spend of capital that way, because the efficiency of the machine, someone would come up with a more efficient machine that charged you less. It's like, well, with this machine, we only charge you a 1,000th of a penny rather than 100th of a penny. It's like, wicked, I'll use that one then. And then the machines sort of pay for themselves. Yeah. So in the machine-to-machine economy, you need limitless transactions, peer-to-peer. You're going to need what Will was talking about, which is this: I need to be able to hop through. I need a lightning network that everybody can join. You're basically saying chatter where the whole of the Minima network is connected, which is what we thought would happen. It's not easy. It didn't happen. Yeah. I don't know the size of the different groups that we have on chatter. I don't know how many people you're connected to, but in the Omnia topology, everyone that you see on chatter, you would be able to pay. You would be able to tip. Is how it would work. There needs to be a path between you and the person you're tipping. The way that this is easily solvable, and this is again something that Will always talks about, which is like, if there's an element of centralization, does that mean it's not a mini DApp? Does that mean it's bad? It's a no-go? And it's like, no, but it needs to be trustless. And so what you do is you call hub and spoke. And so what you do is that somebody will set themselves up and say, you can start a channel with me. It costs capital to start lots of channels. Yeah, I've got lots of capital. I've got lots of minimum. You can start a channel with me. You can start a channel with me. I can start up 10,000 channels. Yeah, it just takes a database entry. Each of you is a database entry. I have the transactions. Now, anybody that is connected to me can pay anybody that is connected to me. Two hubs, two big bad boy hubs, bad girl hubs. Yeah, I've got 10,000 people. You've got 10,000 people. Now there's a connection between me and the other hub. Now everybody on that hub can pay everybody on this hub. And it really simplifies the network. It really simplifies, you're only ever doing 3 hops at maximum. And so, yes, there is an element of centralization there, but it's trustless. I can leave whenever I want. I can leave your hub if I want to. It doesn't matter that there's a little bit, you'd probably be offering better fees because you've got so many people routing through you that you would be able to charge less than somebody who's just out there. This is what happens on the Lightning Network when you try to set up a node. Those of you that have tried, you have to set a fee. And if you're saying, when they were saying who determines the time, who determines all of this, you can determine that. Like, clearly you'll have a default value. Clearly you have some people who say, look, this is how long it's going to take. You might say 24 hours for a settlement. What if I drop my phone? Yeah. And it takes me 24 hours to buy the new phone. Blah, blah, blah. Yeah. You should never, ever actually need to use it. In the normal operation of things, you'll never actually post the update, the settlement, or all that. That's just to ensure that you can't screw me over. The only time these channels are ever closed, we'll just do it in a civil way because there's no point doing it the other way. King J's got his hand up. Yeah, I think that's a hand. Is that he's got a little punk? I don't know if that's a mini punk.
I will invite him now. He had a question. Hello, King J.
Hello,
Okay.
good morning. It's nice to be here. I'm such an inspiring teacher. Okay, I have a question to ask. How does Omnia's implementation of L2 technology improve transaction scalability and security for mini apps compared to traditional layer 2 solutions like Bitcoin Lightning Network? And what specific cases in IoT or vehicle-to-vehicle communication could benefit most from this integration? I've actually asked it in the comment section, but I wanted to ask.
I think I understand. So, firstly, and very importantly, Omnia is very simple. The current Lightning implementation does not have this floating coin thing, which means from a technical level, the only thing I need to keep is the latest transaction. I don't need all the previous stuff. We call that detritus. I don't need any of that. I only need the latest because I know whatever happens, I can always post that and it works. That is a massive simplification. In the current system, you need to have cascading time locks. And if I post a previous transaction, you have to have all the previous transactions so that you can nullify it because of the way, I'm not going to go into the way that is done, but it is really very complicated. And I guess I judge something to be complicated if I find it difficult, because if I can't do it, I'm not sure how many other people can. And the fact that it's simple means that hopefully many more people can write these sort of applications. Many more people can be involved in the low level. Yeah, many more people can actually optimize. Yeah, you want as many developers to be working on this as possible. I saw a very interesting term on the Matrix the other day, and this is intellectual capital. Yeah, you want as big a group, you want as much intellectual capital to be poured into the system as possible. And the simpler the system is, the more intellectual capital can be expended in this system. And the current way the Lightning Network works is complicated. It's hard. It's just not possible for me to write you. I couldn't have written that in 4 days. I just couldn't have done it. It's like, if I can't do it, I don't know who's going to be able to do it. And that has exponential benefits. That has benefits that compounding benefits because everybody's working on it. As far as the IoT devices and the machine to machine, as we were saying earlier, the machines, should we call them that now? The machine people, I'm reading an excellent sci-fi book. The machine people are going to want to pay the other machines aside from humans. They're going to want fast, instant. These Omnia transactions are as fast as you can make them. Now, you may have noticed when I did my update Omnia, it took about 2 seconds. It took about 3 seconds. It was like, I'm signing. That's because my laptop is 10 years old. That's because I don't have a chip. I don't have Minima on chip, which allows me to hash. All it's doing is lots of hashing. Yeah, all the signatures in Minima are hashes, basically, lots of hashing. So that could be instant. A machine doesn't want to sit there for 3 seconds. That's like 20 years to a human. A machine wants instant payments. It wants free. These payments can be. You can actually do 0.01% of any amount. Minima has 42 decimal places. I don't want to set a minimum. I don't want to say the fee for this transaction over is going to be 1 cent. What if I only want to send someone, a millionth of a cent? What if a machine wants to send a machine a millionth of a cent? So the machines need to be able to say, I'll route your transaction for 0.1% of the value, 0.01%. And it's instant. And it costs you 0.01%. Doesn't matter the amount. It doesn't cost me anything, really. Routing your transaction just means shuffling up a couple of transactions, signing a few things. It's like, all right, I want you to do 1 million transactions through me a day. I want as many transactions. The more transactions, the better. That's what I want. That's what IoT wants. They want fast. Yeah, these are instant transactions. There's no delay. As soon as we've signed that transaction, it works. There's no minimum amount that can be sent. There's no minimum amount that can be sent. Another thing about, why this works particularly well on Minima is, as I have said before, Minima blocks don't have to be full, which means that Minima blocks can be big. Every other chain has to have small blocks. They have to have that fee market. Their security is dependent on the number of fees that you pay, which means you've got to fight to get into the block. Minima can have empty blocks and still be secure. Minima can have empty blocks and still be secure because our security is not based on the fees. Our security is based on the number of users. Yes, we need a lot of users. Yes, but if you've got 1 billion machines, if the machine people actually started to use Minima, that game's over. If the machine people started using Minima, it's done. We're secure. You're not overtaking them. And now they can do as many transactions as they want between themselves, instantly and for free, privately. Yeah, it's very, very hard to tell who's paying who. It's impossible if you do it correctly. You've got private, instant, free, limitless transactions over Omnia. What more do these machines want? Yeah, that's what we're offering them in a simple system that anybody can dive into and get involved with. We're not there yet. I'm not expecting the world tomorrow, but I'm just trying to show you that it is a simple system and that with a little bit of effort and a little bit of cunning, it is possible to write some great applications.